Okay, yeah, this is on, great. All right, well, I'm going to get started here. I'm Brian Larsen from Brocade Communications, and we are a networking company. If you are not familiar with Brocade, our history shows that we have been a storage networking company. And I'd like to reintroduce ourselves as a networking company in a lot of different ways. Since 2008, we have made multiple acquisitions and put ourselves right smack into the middle of IP Ethernet switching at very high speed. Does that mean that we've left our storage networking heritage? Absolutely not. We have been a partner with IBM in storage area networking and fiber channel technologies, along with many of the other large storage vendors, almost every one of them. And we continue to evolve that into IP storage solutions. We are evolving our fiber channel capabilities. We heard earlier from one of the guest speakers about NVMe, which is something that we're going to be porting into the fabric. He did announce that, and that is something that we're definitely in the middle of and helping in that space. However, again, reintroducing ourselves as a networking company. And with that evolution is something that we need to take a look at in a virtualized world. And I'm going to try to step you through what that means to Brocade and how it gets applied into and throughout the solutions that get applied to every one of the compute platforms out there. But OpenPOWER and its migration to compete in slightly different markets or compete directly into an Intel market lends itself well to a new market or new use cases. So let me just kind of step you through where we're at. Brocade is landing on a vision of the new IP. We know that the networks of old have basically just run out of gas. And with the number of end user devices, and as you know, you've seen all of the stats, just billions and billions of these different handheld devices, our phones, our tablets, our PCs, Internet of Things. All of that is expanding itself so fastly that the service providers cannot seem to keep up with the amount of data rate that needs to happen, the flexibility that it needs to portray, and the services that it needs to deploy. And with that is a new evolution in what we're calling the new IP. This new IP approach is different than your traditional IP switch vendors. You know the top ones in the world, and this is very revolutionary in the fact that if we take a look at network services, people like to buy and have bought for the last 30, 40 years purpose-built switches. Now our friends at Mellanox, they're very good at InfiniBand. That is not something that we do. Well, in addition to that, there's some of the other vendors out there like Cisco and Juniper who have such a large install base that they cannot disrupt that hardware evolution and continued revenue growth. I mean, they just need to have that there. Brocade has entered into this new IP realm with not a large install base, not a lot of market share, and the affordability for us to be disruptive in this technology. And in looking at this new IP, this is just kind of our approach to it. We're looking at how we do this in a very open manner that clients can do something today. If they don't like us tomorrow, they can take us out and put a different vendor in with no disruption to service. This is what OpenPOWER is all about. So this is an approach that we feel very, very tightly knitted with OpenPOWER and IBM in general, because they've been a very major partner of ours. Innovation-centric again is a software-enabled opportunity. Now OpenPOWER, we've been hearing a lot of speakers talk about the internals CAPI, all of the different real high-speed stuff, high compute things that they can do. That is phenomenal. And I tell you, I am very impressed by all of this, the talk of what this power platform can do. However, the software-enabled capabilities of the compute, the network, and the storage has to take into consideration the solutions on an end-to-end. We're taking a very innovative approach in software enabling the network. Ecosystem driven. If we don't have people to play with and we can put these things together, it simply won't work. Oh, let's go back to OpenPOWER. What's one of their major objectives? Ecosystem friendly. And with that evolution, we need to have storage vendors, network vendors, compute vendors. We need to have all of them put this together, software vendors to put it together so that we can create this open environment that's very reactive, very flexible, very scalable, and can react to what a service provider or an enterprise user wants to use it for very quickly to meet the market demands as it is. And as this last bullet says, your own pace when you want it. This is all about the flexibility built into software-enabled anything, right? Well, if we can give all of these elements to a client in a way that they can approach this that makes perfect sense today and into the future, then we have a way to evolve very quickly. This is going to take some time. It's not going to be an overnight event that happens here. But this is a kind of an overview of what we see. And this is our stack, if you will, when it comes to Brocade and how we're approaching the markets, and with very specific understanding that you will not get rid of hardware. Infrastructure, it will be there, and it will always be there. And if we look at the bottom here, the network, the compute, the storage is at a physical layer. There's no question about it. However, the innovation that you can build into the network for automation, complete automation, is probably not going to happen overnight, but I can tell you what, there are so many different ways that we've already implemented automation into the network. It's reduced operational expenses by up to 40%. This is a virtualized environment that lends itself very well to compute, high-speed compute, and very high-speed storage connectivity. Now, if you just keep going up the stack in this virtualization world, and you're abstracting the physical, this is where we are investing a significant amount of R&D acquisitions. We have been purchasing virtualized network companies for the last 5 years, and we are building out these things for the mobile networks, service provider networks. We're building them out for enterprise class solution sets, and we're creating those within the ecosystem of an open source environment. So in this chart here, it does show these different layers. In our B wing, that is where we're playing. And off to the side in each one of these layers is the assets and what's in our portfolio that we sell in these different layers. We are, and again, looking at the open community, if you look at the network controller layer, server controller, and storage controller layer, you know, when we talk about, we're not a storage vendor, we're not a server vendor, we are a network vendor, and we're very much a participant in Open Daylight, which is another consortium building on the open source community for a controlled environment within the network. And so you start to add these two together and the ecosystem partners that we need, because we are not going to provide this end to end. We need the folks to fill in the gaps. If we don't, then the system breaks. But we have some very strong partnerships both in the physical layer, the compute layer, the storage layer, and then all the way up through other software vendors that are working in the network space. So we're working together in that ecosystem to put it together. Now, is all of this available today, and is it all of it available on an OpenPOWER platform? The answer is no. However, if you're looking at very specific infrastructure like storage infrastructure, fiber channel, if you're looking for 25 gig Ethernet, if you're looking for 10 gig, 40 gig, 100 gig, that's all there. It's all standard. We have all that. But what we see is an evolution towards something that makes it more deployable, faster to deploy, more flexible. And that's where you come right down to software and how it interacts and sits on a compute node. The compute node becomes the virtual router or a network component. And in this instance, I'm just going to take you through what this virtual router, or VNF, you've probably heard or maybe have heard of software-defined networking and virtual network functions. This is a virtual network function. It's a router. Take anyone, Cisco, Juniper, Brocades, doesn't matter. Routing functions and purpose-built units do certain things. Firewall, network address translation. They just do layer 3 routing. If you do firewalls, Barracuda, you name it. They have functions and they're purpose-built. However, they've served their purpose very, very well. But as scale happens in the enterprise and with service providers, how do you keep just adding more purpose-built things? And how do you do it very efficiently without sending out one of your techs out to the middle of North Dakota and put one of these things in? What if you can put that software that we've been talking about, this virtualized image of a router, and put it on an OpenPOWER platform? Can't do it today, but what if? Or you can put it on an Intel server out there remotely from anywhere in the world and deploy it, and you're up and going. And you get that purpose-built capability on a virtualized machine at performance. This is where the world's going, and this is what service providers are asking for. Especially, and I'm going to use the context of cloud because it's very prevalent today in the cloud environments and how it's being deployed. This routing function gives today the ability to gain access from your enterprise out to a service provider, a cloud service provider, and then they can have access to any other cloud service provider. You have choice. It can be deployed anywhere you want it. It is industry standards based. There is no difference between the two. And it interoperates outside the realms of another virtualized instance. But it helps you get to where you need to go very quickly. It gives you all the functions that you're used to and that you need in those purpose-built functions like routing, IPsec, virtual VPN tunneling, firewall. All of those things are in this and are built around a, whoops. Sorry about that. And built around a software-defined instance. This gives you just kind of a high-level view. So if you're in an enterprise and you have built out your own private cloud, fantastic. However, if you're scaling and you need to get into a private cloud, you can go, or a public cloud, you can go to any cloud provider that you want, or any of them, and add them together into providing what you need for services. You don't have to pick one. You can pick any you want. And these virtualized routing instances can reside in all of them. So let me just give you an example. Brocade is the largest provider of a virtual router function in Softlayer. We have virtual router capabilities in AWS, and you name it. We're in Rackspace. We're in every one of those large cloud providers. And it's because of the ease of deployment that this is put in there and the ability and its flexibility to give you more than one service. So, and if we align this with what Softlayer does, this is where, and we know, by the way, that many of these cloud service providers, and we heard earlier today, Rackspace, Google, and by the way, Softlayer, are all going to be going and using, they're probably already using, Power Platforms and OpenPOWER platforms. So the question becomes, will these virtualized network functions need to be ported to the Power Platform? It's a good question. We think it does, but we're still waiting for market demand. Softlayer, though, in this virtualized world that we live in, and especially now in this networking routing function, all of these value adds of what they get from this, using this kind of a virtual routed infrastructure, helps them expand and quickly deploy what is needed for the enterprises who are using their cloud services. And they have this deployed on a worldwide basis in every one of their data centers of all 25 to date. What am I talking about? I don't want to drill down into each platform, but this virtual router, again, has three very specific major functions, if you will, and it's not special purpose. It is all in the same code that we sell. I'm not trying to do a pitch here, folks. I apologize if it sounds that way. But what I'm trying to do is just come to the point where this routing function can be done in software on compute platforms, and it can be as performant as any purpose-built box. It's not going to be used everywhere. However, in certain circumstances, very well applies itself. Cloud service providers and the enterprise, where it's applicable, in their private clouds, very well suited for that. So I'm going to end with this chart here. And it just tries to pull together, I've talked about the enterprise, virtualized instances, the network. The network in and of itself needs to be there to take high-speed compute platforms that takes an output and they put it somewhere, or they deliver an answer to someone. That network has to be there. And it's not just the internet. We can't just say it's just the internet. No, it has to have connectivity to everywhere in the world. In fact, to the point where Brocade on Monday purchased a wireless networking company called Ruckus for $1.2 billion. These are the investments that we've been making since the last 5 to 6, 7 years to expand to the end user endpoint, to you sitting there with your phone, to you sitting there with, or me sitting here with this clicker. or Internet of Things. That volume of data continues to grow, and we need to get access to it. We need to bring it through a service provider network and get it to these high-speed compute nodes where they do their data crunching, they understand what's going to happen, and predict things for the benefit of all of us. So we're trying to combine what we can do with the enterprise, our heritage in the enterprise, looking what we can do with the cloud group, and then how it interacts with telecom, and how we can provide a more efficient, flexible, and capability to deploy very quickly and through a virtualized environment and platform. So that was very quick, just a hair over my 15 minutes, but I know we're way behind. So if there's any questions, I'll be happy to answer, but if not,